Okay, let's see how you're doing on each of these. So for number one, this is addition, which is good. 68 plus a negative 35. So if this is 0, 68 goes in that direction. It's positive. Negative goes the opposite direction, but 35 is shorter than 68. So we know our answer is positive, and it's the difference between those lengths. 68 plus a negative 35 becomes 68 minus 35, which is 33. That's a positive 33. Number two is subtraction. But remember, we changed subtraction to plus the opposite. So the first number doesn't change. The negative 29 stays the same. The subtraction works on the number that comes after it, the 53. So subtracting 53 is the same as adding the opposite of 53. So adding negative 53. So if this is 0, we have negative 29 and negative 53 go the same direction. Tells us our answer is definitely negative. And since they go the same direction, we add the absolute values. 29 plus 53 is 82. So negative 82. Number 3 here is also a subtraction. Again, the first number doesn't change. The subtraction works on what comes after it. So subtracting a negative 68 becomes adding. The opposite of negative 68 is a positive 68. So we have from 0, we have a negative 64, or negative 44, I should say. 68 is positive, so it goes the other direction. And it's longer, so it goes past 0. Telling us our answer is positive, and it's the difference between those lengths. 68 minus 44 is 22. That's a positive 20, not 22, 24. One of those mornings, sorry. 24, so that's a positive 24. Number 4, negative 37 minus, or plus a negative 71. Negative 37 goes this way. Negative 71 goes the same direction. So this is definitely negative. We're on the negative side of 0. They point the same direction, so we add their absolute values. 37 plus 71 is 108. Number 5 is a subtraction again, so we're going to change it. 27 minus a negative 59 is just 27 plus a positive 59. That adds up to be 86. Any questions on those first 5? Okay. Number 6, multiplying or dividing. We don't use the vectors there. We just combine the absolute values and work with the signs. A negative times a positive is a negative. 8 times 3 is 24. For division, a positive divided by a negative is also a negative. 24 divided by 4 is 6. A negative times another negative is a positive. 7 times 5 is 35. Likewise, a negative divided by another negative is also a positive. 30 divided by 6 is 5. And then this last one I just threw in here, negative 28, positive 17 is on the negative side. It'll be a negative 9. Any questions on any of those 5?
Yeah, number 10, ain't that a negative 11?
Oh, you are correct. It is a negative 11. Thank you. Yeah, the difference between 28 and 17 should be 11, not 9. Thank you. Like I said, it might be one of those mornings. Okay, so we worked with those integers, and I realize for many of you, the integers are not a huge part of what you're going to do, but they are out there, and I see a ton of mistakes made with them. So make sure you're at least familiar with them and know how to punch them in your calculator if you have to. So now at this point, we have quiz 1. I know some of you have not accessed Blackboard yet, so I just want to do a quick little review here of accessing Blackboard so you can see where quiz 1 is. So if you go to Blackboard and you click on your course, on the left side here, you click on course information. You scroll all the way down. The week 1 folder here has all the links for the lecture recordings and the homework stuff for last week. You click on week 2, you'll see this is going to be the lecture links for this week, but it also says quiz 1. Well, the quiz is actually in a separate link. If you're Luke, you're in Dairy Herd, you would click on the Dairy Herd one. Everybody else would click on the other one.
But I do
Just
Dairy Herd too.
what's that?
I'm also on Dairy Herd.
Yep. So you would click the Dairy Herd one as well. The rest of you in auto tech or welding will do the other one. Same problem, same numbers, just different wording, so it makes more sense to your program a little bit. Now, if I click on directly on the quiz 1 there in Blackboard, which is what you have to do in order to submit it, it'll take you to this page. You can download the quizzes from here as well if you want. And notice you have 2 options here. You can either upload the document. So if you download it, write on it, and scan it back in, you can click Browse My Computer, and it'll upload. You can find it and upload it just like you would an email attachment. Or if you just want to type your answers in here, you can type them in right here. Did somebody have a question? Okay. So if you just want to type your answers in rather than trying to scan it in, you can just type them in here. Is there anybody that has not accessed Blackboard yet and is really kind of unsure of how to get into it? We're all doing well with it? Okay, good. So yeah, the big key there is to make sure you click right on the quiz 1 word. They said clicking on the links will download the quiz for you, but click right on the word quiz 1 to get to that spot where you can upload it back into Blackboard for me. Doing it that way is going to make it a lot easier for me to make comments and give you feedback on them rather than trying to send them back and forth through email. Okay, so on to our new stuff for the day. I will try to let you guys out a little bit early today just to give you time to go find a computer and print off that quiz if you want to. That'll need to be submitted by noon tomorrow. So by noon on September 2nd. That gives you time. If there are any issues, we can figure them out in class tomorrow to help you get those submitted. Okay, so then, new stuff for today. What we've looked at so far has all been combining 2 numbers with 1 operation. But what happens if we run into something like this? Where we have multiple numbers, more than 2 numbers, and we have multiple operations to do. There are a lot of different ways that could be interpreted. Some might say, well, let's start left to right and just go left to right. And that makes perfect sense. We read left to right. However, that would give you the incorrect answer. Some might start with the subtraction and the easy stuff. But again, that would not give you the correct answer anyway. Every different way that you could interpret that could possibly give you a different answer. Well, in math, we really prefer that if 2 people do a problem, they get the same answer every time. So what we have done is we've defined something to help out with a problem like this called the order of operations. Now, a lot of people mistakenly view the order of operations as a set of steps. And that's not it. You don't do step 1, then 2, then 3, then 4, then you're done. What it really is it's levels of priority. And when we're looking at an individual number, almost always that number will have an operation on either side of it, like the 5 here. There's multiplication in front of it and addition behind it. Well, we have to decide which of those operations has a higher level of priority before we can do anything with that 5. So you might go down and then back up to a higher level as you go from one number to the next. Our highest level of priority is something called enclosing symbols. Now, many of you may have just been told parentheses here. If you learned the old PEMDAS, P stood for parentheses. And that is our most common type of enclosing symbol. But before we're done here today, you're going to see a couple other types of enclosing symbols as well. The next 3 levels are just simply our operation pairs. We mentioned briefly exponents. Exponents are simply the powers and roots that we talked about, or that we mentioned. We didn't really work with them. Next is that pair of operations that we've mentioned several times already: multiplication and division. And our lowest level of priority is addition and subtraction. Now, there are several operation pairs that are left off of this list. Things like exponentials and logarithms. Those actually go in here above regular exponents, powers and roots. Or trig functions and their inverses. They also go above that, depending on the structure of the problem. So this is just for our basic order of operations problems. 99% of problems only include these operations. So we don't have to worry about logarithms, exponentials, and trig functions and stuff like that. Those only occur in that very small portion of problems you would deal with. If we run into any of those, we'll deal with them when we get to it. So now back to our original problem here. 17 minus 3 times 5 plus 6. Well, following our order of operations over here, there are no enclosing symbols. There are no exponents. There is multiplication or division. There's multiplication. I have 3 times 5. Now, the way I typically do it, I make a box around the 2 numbers I'm going to combine, 3 times 5. And then I do that combination. 3 times 5 is 15. So I am going to replace the 3 times 5 with 15, and I have to rewrite everything else. That's why I use the box there. Everything outside the box has to be rewritten. 17 minus in front of it, and then the plus 6 in back. No more multiplication or division. All that is left is addition and subtraction. Now there's one of each. They happen at the same time. So when we have more than one operation that happens at the same time, then we do go left to right, strictly within that operation. So here, left to right, we've got the 17 minus 15. Again, notice I put a box around it. 17 minus 15 is 2. Everything outside the box has to be written exactly as it was, so just plus 6. Now, of course, all that's left is 2 plus 6 is 8. There's nothing outside the box to rewrite, so we are done. The solution to that was simply 8. Well, let's look at some a little bit more difficult than that. So this one here is just a little bit more difficult, has a couple more things in it. So going down our order of operations, we do have enclosing symbols. We have a parentheses here. This thing right here. That encloses part of the problem or separates part of the problem from the rest, which means we have to start in there. Now, inside that parentheses, inside the green box, let's say, order of operations still applies. So we look, there are no other enclosing symbols. There is an exponent, the 3 to the power of 2. Well, 3 squared is 9, so I'm going to replace that 3 squared with 9. Everything outside that box has to be rewritten exactly the way it was. So now we are still working inside that set of parentheses. Inside there, there's no other exponents. So we go to multiplication and division, and we're going to go left to right. The first, we have the 3 times 5, which is 15. Again, everything outside that brown box gets rewritten exactly how it was. Now, I realize this is a lot of rewriting, and the temptation is to try to do 2 or more steps at once so that you don't have to rewrite it over and over again. This is one where there are a couple of things you could do at the same time and it wouldn't affect your answer. Just be very, very careful with it. That's what I find the most mistakes get made on these, one of two things. One is either rewriting the rest of the problem or trying to combine 2 steps at once and they don't work out. You mess something up trying to do 2 steps at the same time. Now we are still working inside this parentheses. We still are doing multiplication division. We have one more multiplication to do, the 2 times 9. That is 18. So again, everything else has to be rewritten exactly as it was. What's that? Oh, sorry, I thought I heard a question out there. Now, we're still inside that set of parentheses here. But all that's left is addition and subtraction. So we're going to go left to right. 17 minus 15 is 2. We have the 2 plus 18, which is 20. And then the 20 minus 4, which is 16. Now we have reduced what's inside that parentheses to a single number. And anytime we have reduced what's in an enclosing symbol to a single number, we are at a spot where we might be able to get rid of the enclosing symbol. Some enclosing symbols, we have to look to see if there's other operations that have to be done first. Some enclosing symbols, many enclosing symbols, we have to look to see if there's an other meaning. Parentheses are more than just an enclosing symbol. They have other uses. One of the uses for a set of parentheses is to signify multiplication. And in this problem, that parentheses is signifying multiplication. The 3 is outside the parentheses without a symbol there. So that is saying that it is 3 times whatever is in that parentheses. So this here is 3 times that 16. Now I can remove that parentheses. I can remove the enclosing symbol if I do whatever it tells me I have to. And in this case, to remove that enclosing symbol, I have to have it down to a single number inside like I do, the 16. But I also have to put in that multiplication when I take out the parentheses. So that was 3 times 16. When I remove the parentheses, I have to make sure it still is 3 times 16. Now there's no more enclosing symbols. There is no more exponents. We do have multiplication here. 3 times 16 is 48. We still have the 5 plus there. And all that's left is to add 5 plus 48, which is 53. Now, like I said, I realize that is a lot of rewriting at each step, but be careful. It's worth it to do it carefully. Saves a lot of mistakes. Well, let's do one that's a little more difficult yet. Just a little bit more difficult. This one looks a little bit like a monster, but it's not so bad as long as we are careful. Follow our order of operations, follow our levels of priority closely. We're fine. So we start out highest priority is enclosing symbols. Well, we have several parentheses here. We said when there's more than one thing at the same level of priority, we go left to right. So going left to right, this is the first parenthesis we run into. Well, we have to see where its other end is so that we can tell what it encloses. Well, this parenthesis faces the wrong way. That can't be its other end. This one here goes with that one. We go all the way down here. This is the other end of that first parenthesis. So we're starting out working inside that parenthesis, or inside that brown box, if you will. Now, inside that parenthesis, the order of operations still applies. So we have to continue looking for more enclosing symbols, and we have it. Right here, there's another in parentheses. So we're going to narrow our scope down to that green box. So in there, we're still applying order of operations. No more enclosing symbols. There are no exponents. So now, multiplication, 2 times 4. 2 times 4 is 8. So I replace it with the 8. Then I'm very careful to rewrite everything else. Exactly the way it was. So we're still working inside this parentheses here, but we only have one thing left to do. 11 minus 8 is going to give us 3. Well, that parentheses is now down to a single number. Now, I'd warned you against trying to combine 2 steps at once, but here's one spot where I usually do it. When I've reduced that parentheses to a single number, rather than putting the parentheses in and then rewriting the whole problem to take it out, I just take it out at this point. Now, I do have multiplication. That parentheses is also standing for multiplication, so I have to remember to put that in front of my 3 there. So now I rewrite the rest of that problem. Now, here's one to be very careful of. This 3 came from the 11 minus 8. This 3 here is still there. It is not gone yet. Make sure you don't confuse the two of them. So now back to the bigger problem. That green set of parentheses is gone. I've completed it. So now I'm back out to the brown set of parentheses here. In there's no more enclosing symbols. There is, however, exponents. I have 2 squared, or 2 to the power of 2, which is 4. So I'm going to replace that with 4. Then I have, also in that parentheses, I have 2 to the power of 3, which is 8. Now still working inside that parentheses. No more exponents, so I'm going to do multiplication and division. I'm going to go left to right. Left to right, the first one I run into is 5 times 16, which is 80. Next, inside there, still doing multiplication and division, going left to right. I have 80 divided by 4. It's going to be 20. Still working inside that bigger set of parentheses. I have more multiplication and division yet. I have the 3 times 3 here, which is 9. Now, inside that brown set of parentheses, all that's left is addition and subtraction. I'm going to proceed left to right. 23 minus 20 is 3. Three plus 9 is 12. And finally, 12 minus 8 is 4. Now, once again, I'm going to be down to a single number inside that parentheses. I'm going to get rid of the parentheses. Again, this parentheses does also stand for multiplication. It's 3 times what's in the parentheses, so that's going to become 3 times 8. So I'm done with that parentheses. It's gone now. I go back out to see if there are other parentheses to deal with, and there are. There's one more set of enclosing symbols over here. Inside there, the first thing we have to do is the 12 divided by 4, which is 3. Now we're down to 5 minus 3 in that parentheses. 5 minus 3 is 2, so we're down to a single number. I'm going to take out the parentheses. However, this time the parentheses does not stand for multiplication. Up here, we had to put in the multiplication because the 3 was outside the parentheses with no operation between it. Here we have addition. So there is no that parentheses is not standing for multiplication. There's no number multiplying that set of parentheses that we have to make sure we put in there for this. So this is just 17 minus 3 times 8 plus 2. Now there's no more enclosing symbols. There's no more exponents, no powers or roots. We're down to multiplication or division. We have the 3 times 8 is 24. 17 minus 24 plus 2. We have 17 minus 24, which is 17 plus a negative 24 would be a negative 7. Plus 2 all comes out to negative 5. Now I realize that one was a mouthful. There was a ton of writing going on there, but it's not horrible. I mean, as long as you follow step by step, don't get impatient, don't start skipping steps, it works out just fine. Well, let's take a look at one that's slightly different. Let's take a look at this one here. To do this one, we first have to figure out what this line across here means. Now, most people would say it means division, and it does mean division. It's called a fraction bar. One of the things it tells us to do is to divide. It is also an enclosing symbol. It separates part of the problem from the rest of it. It's telling us we have to do everything on top separately from everything on bottom. Once we have done each of those things, then we can divide those results. So I'm going to rewrite the top of that so that I can combine everything on top. I'll put it off to the side over here so I have room to work on it. There are no other enclosing symbols. There are no exponents, so I'll do multiplication and division left to right. 7 times 9 is 63. Then I have the 75 divided by 5, which is 15. And now all that's left is that subtraction. 63 minus 15 is 48. So what I get on the top of that is 48. Now to the bottom part, below the fraction bar, there are no other enclosing symbols there, but there's an exponent, 5 squared. 5 squared, of course, is 5 times 5, or 25. Now I have the division. 74 divided by 2 is 37. And now all that's left is the 37 minus 25 is 12. So the bottom of that fraction bar, or that fraction, becomes a 12. Now I can just divide it out. 48 divided by 12 is 4. I have an answer of 4. Any questions so far? So next we have something like this. So here we have this symbol. We're used to referring to it as the square root symbol. Its actual name in math is the radical symbol. The square root is one of the things that it does, but it also does other roots, the third root, fourth root, and things like that. But we're just going to use it in this course, just use it as a square root. It is also an enclosing symbol. You can see it separates the part of the problem that's inside it from the rest of the problem. So we have to start in there. Now, inside the radical, there are no other enclosing symbols. There is, however, an exponent, the 3 squared. 3 squared is 9. Now, there's also multiplication inside the radical that has to be done next. 7 times 9, which is 63. Now, the last thing that needs to be done inside that square root is the 1 plus 63, which is 64. Now, normally I'm down to a single number inside that enclosing symbol. I would remove the enclosing symbol, and I'm going to here. I just wanted to rewrite it so that we didn't lose the fact that that square root symbol, not only is it an enclosing symbol, but it's actually also an operation. So to make sure we can remove it, we have to make sure there's nothing else of higher priority. Well, there are no other enclosing symbols, and there are no other exponents that should happen first. So we can do that square root. We can remove that enclosing symbol. Unlike parentheses, though, we actually have to do something when we remove it. The square root of 64 is 8. However, similar to parentheses, we have to look to see if there's other things that that radical was doing. Not only is it symbolizing the square root, but it is also symbolizing multiplication here. That 3 in front of it is saying 3 times whatever we get from that radical. So this is 17 plus 3 times 8. Now, no more enclosing symbols, no more exponents. We do the multiplication. 3 times 8 is 24. And finally, 17 plus 24 is 41. And that's our solution. Any questions there? So these can be anywhere from a few numbers, pretty simple, to we saw some monsters today, and they can get that bad in the homework. Your homework is page 13 through 14, 1 through 41, the odds. Remember, the solutions for the odds are posted out there so you can check your answers. Just like always, if the first couple seem really simple, and they are pretty simple, feel free to skip ahead to do some of the more difficult ones. Make sure you do at least a few of the difficult ones to make sure you've got it down. On our first unit test, which actually comes up next week, by the way, on our first unit test, there's usually a good share of people that miss 1 or 2 of the order of operation problems because they skip steps. So be careful with those. Also, make sure you have quiz 1, work on quiz 1 in Blackboard. Have that submitted by noon tomorrow. I'd prefer it today so I can get them graded, but I want to make sure you have time tomorrow in class. If there's any issues, we can work through those. Anybody have any questions? Okay, we have 8 minutes here. You are welcome to start on the homework if you would like. I will stay on the network to answer questions. Otherwise, I realize it takes some time to wipe down your tables as you leave. So you guys are free to go if you would like to.